Hey there, and here we go with Finding Angles and Shapes Part 4. Angles in quadrilaterals and triangles. So we kind of already know a little bit about angles in triangles, to be honest, but it's kind of like this one's a bit more mixed up. Plus there's a bit of angles in quadrilaterals, which we haven't really covered yet. Cool. So rule, angles in quadrilaterals, angles in a triangle add up to 180 degrees, that's right. Whereas for a quadrilateral, A plus B plus C plus D, what do they happen to add up to? It's fine if you don't know already. They add up to 360 degrees. Woo, 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 woo. Sweet. So that's a little rule. A plus B plus C plus D. In a quadrilateral, the angles add up to 360 degrees. Don't forget that in a triangle, the angles add up to 180 degrees. And just a little bit of a recap. Why are these two? Why are these two equal? That's right, they're corresponding because they're both on the right, same side of the transversal. Here's the parallel lines, here's the transversal, and they're both in the same position relative to the parallel lines. They're both above the parallel lines. Why are these two equal? It's not corresponding this time because they're on different sides of the transversal, and they're not vertically opposite, they're not right opposite each other. They're equal to each other because they're alternate. See, they form the zangle, whereas these ones form the fangle. So don't use fangle or zangle as official reasoning, please. Call these ones alternate and call these ones corresponding. So why? We already know why now. So why is this one A plus B plus C plus D equals 360? It's because it's a quadrilateral. It's a four-sided shape. The interior angles of a quadrilateral add up to 360. Why does A equal B? They're corresponding angles. Why does P equal Q? They're alternate angles. So what special things are, just a little recap, what do isosceles triangles have that make them special? That's right, they have two equal sides, not just two equal sides, but also two side lengths the same and two base angles the same. So here's an isosceles triangle, do a little sketch of an isosceles triangle, put the little dashes, or I call them sticks, to say that they're the same length, and it's the two base angles that are the same. You can see those two are the same acute base angles. This is an obtuse one in this case. So isosceles triangles have two side lengths the same and two base angles. The base angles are at the end of the side lengths that are the same. What do equilateral triangles have that make them special? That's right, they have all three side lengths the same. Oops, sorry about that. They have all three side lengths the same, so all three side lengths the same, and all angles are 60 degrees, like that particular one. And then right angle triangles have a 90-degree angle in them. Nothing special about the side lengths, they just have a 90-degree angle in them. So as equilateral triangles look like this, all three side lengths are the same, so put a stick on each one, and all the angles are 60 degrees, because 180 divided by 3, because they're all equal, equals 60 degrees. So let's do some examples. Don't forget, you must always give reasoning too, like corresponding angles, or vertically opposite angles, or co-interior, or corresponding, or alternate, or adjacent, and so on. Find the angles marked with letters. So we've got A, B, C, D, E. Maybe let's go in alphabetical order to make things interesting. Can we go in alphabetical order? That was one thing. This might be an example of one where it's a little bit tricky going in alphabetical order. Oh, no, we can. See how we've got two parallel lines here? Two parallel lines here, and we have a transversal here, and we have a different transversal going on here. They're both transversal, so that's a transversal, and that's a transversal. These are the parallel lines. So A has a relationship with this one here. What's the relationship between 68 degrees and A? That's right, they're corresponding. So A equals 68 degrees. The reasoning is corresponding angles. What about B? What's the relationship between A and B? If we know that A is 68 degrees, B must be 68 degrees too. What's the reasoning? So notice we have a zangle going on, so it's alternate angles. So B is 68 degrees and it's alternate with A, that's why. What about C? So C, let's see, can we work out C from anything else at this point? Oh, C equals 60 degrees, which is 180, 180 minus 120. So see how we've got the What we've got here is we've got a 120-degree angle here. We also have a transversal here. So this angle here of 120 is equal to B plus C. Do you see that? So see if that's our transversal this time. Because you could always extend that transversal if you like. Try to imagine if that transversal was extended. If that transversal was extended, then this little angle here is the same as that little angle there, as B plus C. So B plus C equals 120. And so we know that B is 68 degrees. Okay, hold that. Sorry, I thought this said C, but no, it doesn't. It's E. So if you're working out C, you could work out C, because C is, will it be equal to 120 minus B? But at the moment, sorry, this is an E. That's an E there. So here they're just saying that E is 120 degrees, and the reason is that it's adjacent. Angles on a straight line add up to 180. So E, sorry, is equal to 60 degrees, because B plus 120 add up to 180. Okay, but moving right along to, okay, A plus C plus E, we know A, we know E, how can we work out C? A plus E, C plus E equals 180. So C equals 180 minus 68 minus 60. So we know that's 60, we know that's 68. So C must be 180 minus those two angles that we know already. So C is 52 degrees. So we've got that. D is 60 degrees because C, we've got this red transversal. So D plus and E are alternate. So D and E are alternate because they make this angle. So D and E are alternate, so they're equal. So D is 60 degrees because it's alternate with E, and we know already E is 60 degrees, and so on. Degree signs only required in the final answer, just a reminder of that. Okay, thank you very much.